everyone, welcome back to our channel. I hope you and your family members are doing good because that is the most important thing, and for rest we are here to talk. So we were following our pattern wise DSA sheet and doing linked list topic, and we were on fast and slow pointer. So today we'll see the third question, which is linked list cycle 2. So let's read the problem statement. The question says we'll be given a linked list, and if there be a cycle, we have to say the first node of this, like from where the cycle start. So as you can see, example number 1, the meeting point where the cycle starts is 2. So we have to return this. Okay. Similarly, in example number 2, as you can see, the meeting point is 1 itself. So which is at node index 0. And in example number 3, there is no cycle. So we have to return null. Okay. So also, as you can see the position here, the question says ki the note that position is not passed as a parameter. It's just for our reference to understand the problem statement. Now seeing the constraint says 0 to 10 power 4. Definitely you know when 10, like the number 10 power 4 goes beyond 10 power 8, then there might be a situation of getting TLE. But for sure beyond 10 power 9 we'll get TLE. But in this case, as you know, in linked list we always do the linear solution, either in brute force or optimize. We rarely solve any n square type solution. So TLE is not our main concern here. If you still have doubt what I said, we have discussed everything regarding time and space complexity in our full video. I'll add this link somewhere here. You can definitely check it out. So let's do this problem with the fast and slow pointer. In the linked list, we have done the basic operations. Fast and slow pointer we are doing. After that, we will do reversal pattern, and after that we will do merge or sorting algorithm type linked list based questions. So out of all these patterns, definitely the question applies to fast and slow pointer. Why not reversal? Here we don't need to reverse anything. Why not merge? Again, here we don't need to merge or sort anything. So definitely fast and slow pointer. Because of one more reason, in previous problem where we have to detect there is cycle or not, we solved using fast and slow pointer. Because by moving slow with one speed and fast with double speed. So when we move with double speed, definitely if there is a cycle, slow and fast will definitely meet at a point. Correct? So following the same rule, now we have to detect what is the starting point. Okay. So now let's try to move our slow and fast pointer here. So let's do the dry run now. Suppose we have to start our fast and slow pointer from the head pointer. Next time our fast will move for 2 distance and slow will move for 1 distance. Correct? Now again, next time what will happen? Fast will take 2 jumps because fast is moving with 2 speed, and slow will take again 1 jump. Correct? Now again fast will take 2 jump now from here, and slow will take 1 jump now here. Again next time fast will take 2 jump, 1 and 2, and slow will take only 1 jump, means here. Now again slow will move for 1 time and fast will move for 2 times. So now at this node, which is 5, we can say yes, slow and fast met. But we have to give this, like here if we will return this node says ki at this point they met. It means there is a cycle, but it does not guarantee ki this is the starting node. So to get the starting node, wherever you met this point, correct? So let's keep our slow pointer as it is, okay, and let's remove the fast pointer, okay, and now start a new pointer, or let's say the fast pointer from head. And now the rule is, let's move both by same speed. So next time fast will come here and slow will come here. Next time fast will come here and slow will come here. So now the node again where fast and slow met, now this time with the same speed, that will be the node where the cycle starts. But how we get this? There is a proper definition or proper proof for that. Let's do that. So did you remember ki where they met? Yes, V. 5. Okay. So let's color this. Okay. Ki they met at 5. Done. Okay. Now we have to give the proof. Correct? So let's say the node where the cycle starts, like from the 0 node, head node to this, let's call it length A. Okay. Now let's call this length from the point where the cycle starts to the point where they met, let's call it B. Okay. Now, so where slow and fast met, can I say ki slow has covered the distance A plus B? Yes, so let's write it. Slow has covered distance A plus B. Yes. Now, what is the distance fast has covered? If you remember, fast moved like this. Can I say? Yes. It covered A also, it covered B also, and one cycle also. Can I say that? Okay. So, can I say fast has covered A plus B and the cycle? Now, in the cycle, what we have? It covered cycle for one time, correct? But it could have covered cycle for 2 times, 3 times. So, let's say the cycle is K. So, can I say plus n times K? Again, what I said, slow has covered distance A plus B, done. You only saw ki fast has covered like this. So, this is nothing but A, this is nothing but B. So, I have written A and B and one time cycle. So, let's say cycle is K. So, one time cycle means 1K, 2 time cycle means 2K. It might have covered 2 cycle also, okay? Okay. Now, I know fast is moving 2x distance. So, I can surely say one thing, like if you remember in a straight line, you know now, whatever distance fast has covered, slow has always covered half of its distance. So, if we write 2 times S, that will be equal to F fast. So, the same thing we have to write. So, slow means 2 times A plus B is equivalent to A plus B plus NK. Yes. Now, 2A to B. Now, when we will subtract A and B, so can I say this will become A plus B is equal to NK. Can I say that? Okay. Now, can I say A is equal to NK minus B? Yes. What is A? This. Now, from NK, again from NK, which is cycle, when you will subtract this B, can I say I got this? Again, in this case, it was 1K. So, can I say it was one cycle? So, from this one cycle, when you will subtract B, can't you say this is left? Means from this cycle, when you subtracted B, can I say I got this? And it is saying this A will be equivalent to this. And hence, that was the reason I said that when it met, restart from here, move both with the same speed. Now, wherever it met, this will be the starting node of the cycle. So, this was the proof of this formula. Can we write the code for this? So, we will start our let's say list node, let's say slow pointer also from the head, and we will start fast pointer also from our head. Now, because fast is moving ahead, so it might happen ki there is no cycle. So, definitely in this case fast until fast not null and fast dot next not null. If you don't know why we are writing this condition, definitely you should check the very first video of this fast and slow pointer, where we have solved the problem to calculate middle point of the linked list. Because of the even and odd length, we write this condition, means both fast and fast dot next should not be equal to null. Now, we have to move our slow and fast again and again, okay? So, slow is equal to slow dot next with single speed, and fast is equal to fast dot next with double speed, okay? Now, we have to write if they met, if slow is equal to fast, remember? If slow and fast met, what we did, we started a new pointer, let's say list node, let's call it new node instead of fast, okay? Let's name it new node is equal to, again we have to start from head, correct? Now we have to continuously run both pointers, means slow is equal to slow dot next, yes, and new node is equal to new node dot next. But we have to do this continuously, means can I say we have to put this in a while loop. So, here before moving this, we have to write ki while our slow is not is equal to new node, we have to continuously do this, okay? Yes, and if it is equal, so at this point we can return what? New node, that's it. Or else after coming outside the while loop, if this while loop comes out, it means for sure we have not returned anything, means there was no cycle. So if there was no cycle, we have to return null, correct? Saying no cycle means no starting point. So let's run the code. Done. Now let's try to submit this. So talking about the time complexity, as you can see, fast has moved from head pointer till null. So definitely the time complexity is O of n. Is it exactly O of n? No. It can be 2n, 3n depending upon where that fast and slow met. Because if you see here, this was nk, okay? So if we say n, O of n means till 6 only one movement, okay, means one time. But as you can see, fast has moved double, right? So it will be O of 2n, 3n, 4n depending upon where they met. So we can say kn, but definitely this will be linear. Okay, now talking about space complexity, we have not used or taken any extra space instead of these two pointers. So the space complexity will be constant in this case. Okay, so I hope you understood. This was your Java code, and here is your C++ code with a similar approach if you are from C++ background, and here is your Python code if you are from Python background. So I hope you understood why only fast and slow pointer, and also with the proof, because in the interview when you directly write the code without explaining the proof, that will not make sense. So definitely remember the intuition behind this formula instead of just remembering the code itself. So if you understood, definitely you can go in the sheet and mark the third question also as done. I hope you will solve this on your own, and if you have any doubt, please do let me know in the comment section, and please make sure to subscribe and like the video. And if in case you don't have the sheet link, I'll add the sheet link and all my social media links below in the description. You can reach out to me for any kind of guidance. And that's it for this video. Let's meet in another video with some more interesting questions, topics and patterns. Till then, keep learning, take care of yourself and your family.